Okay, so moving on, part two. Okay, so what we looked at so far, when we looked at two separate genes, we looked at them at two separate chromosomes. Okay, because chromosomes are individual solid structures and they move separately from one another. Okay, so chromosome 1 and chromosome 2, for example, are two physical objects. Okay, and so they move separately from each other. They segregate independently of each other. Okay. Now, genes on different chromosomes are inherited separately. So if you inherit one version of chromosome 1, it doesn't matter which version of chromosome you inherit. So a 50% chance of inheriting one versus the other. Okay, so they're inherited separately. However, genes on the same chromosome are inherited together. Okay, not 100%, but they're linked, which means they have a higher percentage of ending up together. Okay, so like here, for example, okay, if they're completely linked, there will be no one in this group. Okay, oops. Hello. Oh. Screen one. There we go. Okay, if they're completely linked, there will be none in this group. Okay, if they're completely unlinked, then all these four combinations will be 1 and 4. Okay, and neither of these are true. Okay, so they're mostly linked. They're more similar to this result, and that's, you know, they're mostly linked together. So they're usually inherited together. Okay, if they're on the same chromosome, they're usually inherited together and they are linked. Okay. Okay. Punnett squares and product rules. Okay, these are more unlinked objects. If they're linked together, then they usually stay together. The only time they become unlinked is during crossing over. Okay, because crossing over, I can swap little bits of DNA everywhere, and I can come it, like I can occasionally have a crossing over event. Okay, between 1 and 2, and in genetics, in real genetics, we can calculate that, but you guys don't need to know how to calculate that. Okay. Okay. All right. So now with the intro to Mendelian genetics, now we're getting to non-Mendelian genetics. Okay. Not all genes work this way, where there is a dominant and there's recessive and there's nothing else. Okay. Incomplete dominance creates a new phenotype. Incomplete dominance is where one gene is not strong enough to be dominant over the recessive, and you get somewhat of an intermediate phenotype. Okay. So incomplete dominance, red and white make pink because you do not get enough of the red gene to make all red. Okay, but you have enough of it to make it not white. Okay, so in humans, there's a gene that causes high levels of cholesterol, really high levels of cholesterol. Okay, and that is a homozygous dominant gene. Okay, but if you have one copy of it, then you end up somewhere in the middle. You don't have a high cholesterol, but it's not like off the charts high. Okay. Okay, so co-dominant genes. Okay, another example of co-dominant genes. Codominant genes do not match each other. Both of them are expressed. Okay. The most obvious one of these is your blood type. You have three alleles for blood type: A, B, and O. Okay. A is dominant over O. B is dominant over O. A and B are co-dominant to each other. Okay, which means if both of them are expressed, okay, if you have both of them are expressed, and that's where you get a phenotype A, B. Okay. Okay. Pleiotropy is where one gene has multiple effects on phenotype. Okay. Like, for example, in this case, you have a gene called that encodes a connective tissue protein. Connective tissue, you'll learn, is present in everything. Okay. And therefore, if you have a mutation in connective tissue, then you will have major issues everywhere. Okay. This is called Marfan syndrome. You have problems with your eyes, you have problems with your bones and joints, you have problems with your blood vessels. Okay. Everywhere. Okay. One gene, many phenotypes. Okay. Like one of the genes that I used to study was insulin and insulin growth. Okay. So changes in insulin actually has multiple effects everywhere. Okay. Okay. Sex-linked genes have unique inheritance patterns. Okay. Sex-linked genes are always, in your case, on the X chromosome. And that's true like 99% of the time. Okay. So the X chromosome. Okay. Females have 2 X chromosomes, males only have 1 because males have a Y. Okay. Go ahead. So most human sex-linked traits are controlled by genes on the X chromosome. Okay, so males only have 1 allele for the X chromosome, females have 2. Okay, so diseases are usually caused by mutations that screw up the function of a gene. Okay, males only have 1 copy. So if that 1 copy doesn't work, the male is screwed. Females usually have 2 copies. So 1 copy doesn't work and 1 does, then you're okay. For males, it takes you 2 copies, or for females, it takes 2 copies for you to be screwed over. So that occurs literally much more. Okay, let me give you an example. This disease that they're talking about here. Okay, this is hemophilia, right? This is blood transfusion problem. Yeah. So hemophilia is a disease where you bleed a lot if you get a scratch. Okay, males. Okay, so here's males. Okay, if you have a carrier, the female has 1. So the female has 50% chance of being healthy and 50% chance of being a carrier. It has no chance of getting the disease. Okay, the male has 50% chance of being healthy, but 50% chance of getting hemophilia. Okay, so to be a hemophilia female, the father has to have hemophilia and the mother has to be a carrier or have the disorder. Okay, so that's really rare. The chance of a female having hemophilia is literally 1 in a million. Okay, the risk of a male having hemophilia 1 in 1,000. So you can see that literally is 1,000 times more. Okay. Okay. So, okay. Okay. X inactivation prevents double dosing of gene products. Okay. X inactivation so like I said earlier, females have 2 copies of X, males have 1. So that's not fair. Okay. And it doesn't work on gene levels because you can't have like half the gene double in the female and only single in male. So what happens is in females, you have 2 X chromosomes. Okay. Very early in the embryo, in each individual cell, one of the X's turned off. And so you're only using one of them. And that X that's turned off is actually called inactivation. Okay. So here on this cat, this is a very famous other cat called calico cat. Okay. You have in the females, you have splotches of black fur and splotches of red, yellow fur or orange fur. Okay. When you turn off the orange gene, the black one is expressed. When you turn off the black gene, the orange one is expressed. Okay. In males, since they only have 1 X chromosome, they'll either all be orange or all be black. Okay. But never both. Okay. Okay. Last thing I want you guys to understand in this chapter is how to read a pedigree. Okay. So a pedigree, okay, is pretty simple. Okay. A square is always male. A circle is always female. Okay. A line usually means marriage, or it used to mean marriage. Okay, but in reality, it means having sex and producing offspring. Okay, so these are the children of number 1 and 2. These are the spouses of children 1 and 2. Okay, this is generation number 1. This is person number 1 in generation 1. This is person number 2 in generation 2, or person number 1 in generation 2. This is person number 1 in generation 3. Okay, so make sure you understand what these terms mean. Okay, the filled-in ones or black ones are carriers, or sorry, the filled-in ones means affected. The half filled-in ones mean they're carriers. Okay, and the empty ones mean they're normal. Okay. Okay, in this pedigree is autosomal dominant. Autosomal dominant means you only need 1 copy to have the disease. And that means there are no carriers. So you only need 1 copy to have the disease. Okay. What you'll see, okay, is this, right? This pattern of every single generation, you'll have a member with it. Okay. Okay. This is recessive. Okay. So carrier, carrier, carrier. Only when you have 2 carriers do you ever get people who have the disorder. Okay, so this autosomal recessive mutation will usually skip generations. Okay, this X-linked recessive condition, you will see the same pattern. You skip generations, okay? But in an X-linked, only males get it, okay? Females never get it, okay? So hopefully that makes sense. All right. Sorry, I thought it was done. One last concept, because this is really an important concept to take forward into the next couple of chapters. Okay. Most traits that we discussed so far are kind of unique. Most traits, actually, the traits that we actually deal with most often are something called polygenic traits. A polygenic trait is that it is affected by more than one gene. Okay, so people are not just tall or short. People are not just black or white. People are not just dumb or genius. Okay, intelligence, height, okay, skin color, all have many genes that control them. Like actually more than a dozen. Okay, and so you get different combinations. Okay, so for skin color, if you get more combinations that code for dark skin, your skin color will be dark. Okay, if you get more combinations that code for light skin, your skin will be lighter. But on average, the average is ends up being much more likely than all of them being heads or tails, like dark or light. Okay, like if you flip a coin 10 times, there is a chance that they'll all end up heads. There is a chance that all end up tails. Most likely, you end up in the middle. So the middle ends up being more populated than the ends. Okay. So, for example, in this, more people end up in the middle than people who are really dark or really light. Okay. All right. Hopefully that makes sense. I will see you guys